In the year 2560 BC, the Egyptian Empire baked under the desert sun. Thousands of laborers were hauling massive limestone blocks to construct the Great Pyramid for Pharaoh Khufu. Meanwhile, thousands of miles away, caught in a heavy, blinding snowstorm, woolly mammoths were still walking the earth. You might have seen the popular internet myth floating around that these two worlds collided, or that the Egyptians used mammoths as prehistoric heavy machinery to build the pyramids. To be clear, they did not. These populations were separated by thousands of miles of ocean and ice, completely unaware of each other's existence. The true significance of this timeline overlap is biological. A quintessential Ice Age creature somehow outlasted the glaciers by thousands of years, surviving deep into the era of written history and organized human empires. The final survivors held out here, Wrangel Island, a tiny, freezing speck of land in the remote Arctic Ocean. Their isolation was a geographic accident. At the end of the Pleistocene epoch, around 10,000 years ago, rising global temperatures melted massive ice sheets. The rising sea levels flooded the land bridge, completely cutting the island off from mainland Siberia. This watery barrier acted as a sanctuary. While the mainland warmed and human hunters spread across the continents, a small herd on Wrangel Island enjoyed stable environmental conditions for over 6,000 years. Radiocarbon dating applied to remains like this tusk proves the population did not slowly dwindle. They remained consistently stable throughout the millennia. But geography is a double-edged sword. The ocean saved them from mainland threats, but it also trapped them in a finite space with absolutely no escape route. Then, around 1650 BC, the radiocarbon record abruptly stops. The mammoths vanish from the fossil record without any sign of a slow generational decline. For decades, the leading scientific assumption for their disappearance was a theory known as genomic meltdown, the idea that extreme inbreeding ultimately killed off the isolated herd. This diagram shows the severe population bottleneck they endured. The founding population was reduced to a mere 8 individuals, before recovering to a stable herd of roughly 300. Biologists assumed breeding within this tiny pool guaranteed the accumulation of fatal genetic defects. When you shrink a gene pool this aggressively, the math usually dictates that the species will slowly breed itself into unviability. It is the textbook danger of an island trap. But modern forensic science provided an alibi. Researchers recently sequenced the DNA from Wrangel Island mammoth fossils, like this ridged tooth, and compared them to their mainland ancestors. The data revealed a massive twist. The mammoths were not suffering a meltdown. Over thousands of years, they had successfully purged the most highly harmful, fatal mutations from their gene pool. Despite having incredibly low genetic diversity, this herd was remarkably healthy, biologically stable, and theoretically capable of surviving indefinitely. Their DNA clears them of a genetic death. If genetics didn't pull the trigger, the cause of their abrupt disappearance had to be an external, sudden, and highly lethal event. To find the real killer, researchers looked at the chemical signatures locked inside the mammoth bones, signatures that point to a sudden, acute crisis, rather than a generational decline. The culprit was an extreme weather anomaly known as an icing event, or rain on snow event. This happens when heavy rain falls onto a deep layer of snow and immediately freezes, forming a solid, highly reflective sheet of impenetrable ice. For a mammoth, the mechanical consequence of this weather is devastating. Their entire food supply of tundra grasses and moss was instantly locked beneath a crust of solid ice. The disaster moved with brutal speed. Unable to break through the thick ice to graze, a completely healthy herd of massive herbivores starved to death in a matter of weeks. This exposes the terrifying reality of island refugiums. Even the most genetically robust population cannot adapt when its sole food source is suddenly and absolutely removed from the ecosystem. This chart tracks the timeline of Egyptian dynasties on top against the survival of the mammoth population below. When the mammoths finally starved to death around 1650 BC, Egypt had moved far past the era of pyramid building and was entering its second intermediate period, a time of political division and foreign invasions. Human expansion might have eventually reached the freezing shores of Wrangel Island, but a freak accident of nature got there first. Extinction does not always arrive through a slow genetic decline or the relentless pressure of human hunting. Sometimes a perfectly healthy, isolated population simply loses a sudden, catastrophic roll of the environmental dice.